First, just for safety reasons, do not touch any of the soldering irons on here. They're extremely hot right now, and you will burn yourself, so just heads up. So, we're going to kind of teach you the basics of electrical, and we're going to start by a process that we use all the time called soldering. So, obviously you guys know what wires are, right? So wires have different gauges, right? The gauge is the diameter of the wire. So see how this wire has a much smaller gauge to this one, right? So when soldering wires, you preferably want to use the same gauge just because it's better overall for connection wise, and you run into less issues. Do you have that crimp box? So there's two ways you can connect wires, right? The first one is they're called crimps, and they're a little. All right, so these are crimps, right? So when making electrical connections, we use these a lot. So these are what's called butt splices, right? You put a wire in one end, a wire in the other, and then you crush the metal tip onto the wire contacts, and it makes a connection and it will hold the wires in place. These are male-female connectors, right? And I should probably use the same colored one. Doesn't matter. But essentially the way it works is that you have a male and a female end, you crimp these on each end of the wire, and you're able to connect and disconnect however you want. Then what you guys will see commonly, there are these eyelet rings, and we use these when connecting to like motor controllers. So motor controllers are connected with a screw, and so we crimp this on the one end of the wire, we'll drop a screw through and hold it down, and that's how you'll make a connection. You guys can see right here, normally there'll be a screw right there. This is a great example of how we use them, right? So this is how you connect the fan to give it power. And so there's lots of things you can do with electrical. Here's what's called a limit switch. Those of you in programming might want to use these. Essentially what it is when this is pressed, it sends an electrical signal, and the coders can use that in many ways. A lot of it's used for like emergency stops. So if we have an alarm, this will stop it before it reaches like a dangerous point. We can also use them just for information. 2 years ago we used them. We had like a light rail system on the side of our robot, just an LED piece. But when it would hit the next one, the next series of LEDs would light up, so it would like light up as it went. It was stupid, but we had fun with it. So these are all kinds of connectors. These are, actually I have no idea what these are called. Let's call them sticky pads. But essentially what you can do is you can put these on your robot, and then you run a zip tie through them, and you can tie down all your wires, keeping all your wiring nice and neat. Heavily recommend for you going into electrical. So, more about the tools of the trade. These are wire strippers. Essentially what they do is they remove the rubber insulation around wires, allowing you to get to the metal contacts. These are a stripper-crimper combo. So you can strip insulation on wires, and then you can also crush these crimps using a tool like this. So what you'll do is, it's fairly simple. You place your wire inside your crimp, and then you simply crush the metal, making a connection. Pretty easy. These are what are called dikes. They're a crimper and cutter combo. These are very nice for cutting zip ties, wires. So normally I'll carry a pair of these and a pair of strippers with me when I do electrical work. You know, you can just swap back and forth between the tools, and you can get most jobs done with just these two. So, on to a bit more of a complex topic, soldering irons. So let's say you want a very permanent connection, right? The nice thing about crimps is that they're easily removable and easily replaceable, right? So say you need to make a quick connection, you crimp something down, you're done, right? But the thing about crimps is that under stress they'll break. Wires will just come right out of them. And most of the time it doesn't happen, but obviously during a robotics competition, your robot's going to be under a lot of stress, and that will happen. And another thing is that crimps are easily removable, so you can just kind of cut them off and restart. Solder is when you want a very continuous cable, right? So let's say you have a motor with that has been used in previous years, and say it has like about 2 inches of wire left, and you want to extend the amount of wire coming off the motor, right? We'll do something called soldering. So what soldering is we make an artificial connection between 2 ends of wire, right? So this is a perfect example. You see how this wire is sticking out like this? So this is what happens when you strip the insulation off. This is what you'll see. So what we'll do is we'll take 2 splices of wire, we'll tie them together, right? And then we'll take what's called a soldering iron, right? And these are you have to be very careful when working with these. You will burn yourselves. I've burned myself many times. You hold them underneath the metal contacts, right? And you let the metal get hot, right? And obviously when you're doing this, you have to be careful because the wire will get hot through thermal conductivity. So you want to keep the tip underneath, right? Because the tip's the hottest part of the iron. When you keep the tip underneath, the wire will start to heat up. And then you'll take this, it's called rosin core, right? So what rosin core is rosin core is a metal with a very low melting temperature, right? This stuff, it melts with under like, I think it's like 100 degrees Celsius, which is like the boiling point of water, right? Most coppers and irons, which you'll use, most of your wires will be copper. If you find a non-copper wire, I would be very interested to see it. It has a very high melting point, which is the nice thing because it conducts electricity without melting, right? So what you use rosin core for is you use rosin core to generally fuse 2 pieces of copper wire together, right? So you tie them together and then you fill the gaps with rosin core, right? So as you heat the metal, the copper will remain intact, but the rosin core will melt and it'll fill in all the space in between the wires, and it'll remain there. And so I like to call it like the wires suck in rosin core, because it does. The wires will pull rosin core in and then it'll spread it throughout the wire, right? And so you generally want to fill up just enough to where you stop seeing like the edges of the wires. So you see how you can kind of see the individual strands? You want to do it till it looks almost solid. And then that's when you can remove your iron. And rosin core has a nice property due to its low R factor of that it cools really quickly as well. So you'll heat up your iron, your rosin core will melt, and within 3 seconds of removing your iron, your rosin core will be solid, right? And then we take something called heat shrink. Heat shrink is this amazing rubber material that, guess what? It shrinks when you apply heat. It's super cool. So what you do is you use heat shrink to replace the insulation you stripped off earlier, right? So let's say you strip a piece of wire, and you put them together, right? Solder it, so you have a solid piece of wire, but now you have a gap of metal in your wire, right? If any of you know any basics about electrical work, you don't want gaps of metal. So what you do is you take a piece of heat shrink, you'll put it on your wire before you start soldering, trust me, before you start soldering. Then what will happen is you'll solder, you'll pull your piece of heat shrink back over, you'll apply heat, right? Generally we use, it's called the microwave, it's like a portable heat gun, and in my case, like when I do soldering at home, I just use a lighter, but I don't recommend. You burn yourself pretty easy. So let's learn how to solder. Okay, so this is a nifty tool for helping learn how to solder, and even if you know how to solder, it's very nice if you're doing kind of larger projects. These are called helping hands. Speaking of which, it's missing a hand. But essentially, it's just an alligator clip, and what you can do is you can put a piece of wire in the alligator clip and it'll hold it in place for you. When you're inexperienced and you're still learning how to work with a soldering iron, these are very nice. So you just take 2 alligator clips and you can hold your wires right in place. So I think I saw the other end in the drawer where we found these, the other alligator clip. So first off, I'll do a very basic kind of show and tell. I'll walk you guys through the steps of how to solder. First thing to learn about soldering irons is that they take a little bit to heat up. So it's very possible this thing doesn't even work. Yeah, we'll just use one of the old schools. So I kind of gave these a minute to heat up earlier. I don't know if they're actually heating up. They're not. There's no switch on this. Hey, it works.
That works fine.
Oh, cool. Thank you. Cool. So this will make this a lot easier for you guys. I assume some of your upperclassmen probably learned this last year, and so you'll be able to help out the new kids a bit. Okay, cool. So this is a very nice soldering iron. These ones are what I like to call the ghetto ones. You basically plug them in and they turn one temperature and that's it. They just get hot. These are kind of the more high-tech ones, and you can actually set what temperature you want your soldering iron to be at. So a lot of things people don't know about soldering is that you can actually burn your solder. And so generally I use 220-ish degrees Celsius for soldering. And there's quite a few tricks of the trade, I would say. So the first thing that a lot of people don't know about soldering is that you want to do something called priming your tip. It's not hot yet. That's also a really good way to tell just how hot your tip actually is. So what priming your tip is you take your soldering iron and you place just a little bit of rosin core on the start before you do anything, right? And what this does is this gives your soldering iron a nice point of contact with your wire to help transfer heat much easier. Fun fact about soldering, they used to solder with lead. And the thing about lead is, it's very poisonous. And when you melt things, it releases vapors. And inhaling lead is not a good idea. So in the, I think it was the 70s, they switched over to this stuff called rosin core. This is organic core. So this is going to take a little bit to get hot. Let's see if one of these are hot. Yep. So look, this is literally how quickly solder melts. Right. So, alright. So mind you, these soldering irons aren't very good. They're very old. They've been through quite a few years of people not knowing how to solder using them. So just as a heads up, when you try to use them, there might be issues like parts of the tips don't get hot anymore because of buildup. So I'm just going to make a continuous circuit using this wire. So if you guys don't know, your strippers show what gauge of wire you want to use for your hole, but when you get better, you kind of just know. So when you solder, you want a lot of wire to work with, because you want to get a really nice twist when you thread them. Okay, so what I like to do when I solder is kind of try and thread your wire together, right? And you want to make sure that your wires are lying as flat as possible. And then it's kind of hard to do because it's connected, but I like to twist the wires in on each other. Just gets a really nice connection. Actually, I already slipped up. I already made a mistake. I told you guys not to do. I have to put our heat shrink on first. This is a perfect example. Sometimes you don't have the ability to put heat shrink on later. So if I connected this, how would I have got my heat shrink on? Exactly. Alright, so you guys really have to be careful when you're doing this part because copper wires are really sharp, especially when you cut them off like that. Like they jab and stab you. So, use your helping hands. Right. So, this isn't really the best because this is a really thick gauge wire. It's kind of hard to work with. I'll recommend you guys use this thinner wire to start out. So then, you'll take your solder iron. You have to be very careful with your cords because I've done this where I just kind of absentmindedly working touch the cable with the soldering iron and you'll melt your cable. You really don't want to do that. So prime a little bit and then you'll place it underneath. And as you guys can kind of see that the rosin core kind of sticks to the copper and this is what gives you a really nice connection. And then it'll take a minute for your copper to get hot because copper has a much higher melting rate than rosin core does, so it'll take a lot longer to get hot. But priming your rosin core really helps speed up this process. So you kind of want to give it a little. You can kind of just touch it, the rosin core. If your rosin core starts to melt, you'll know you're hot enough. So, I always learned that you want to hold your solder iron underneath your wire, and this way the heat rises up through the wire to the top. So when you start soldering, you know that your wire's hot enough. Some people I know, they'll just go straight from the top. Kind of personal preference. If you go from the bottom, you have to wait longer before you can start soldering, but I feel like it gives a much better connection. If you guys kind of want to see an example of how heat transfer works, you can touch kind of the side of the wire right here. And you can feel even through the insulation how hot the wire is.
You told certain people to make sure they tie that on hair back?
No, not yet. Yeah, definitely the less you have in your way, the safer you're probably going to be.
And you can burn your hair.
Yeah, that's it.
Not a good smell.
Oh yeah. The smell used to give me headaches. Yeah, my senior year for my engineering internship, I did a project where we soldered 864 LEDs together, and the smell of solder made me sick after that. It took me like 6 months to do. See, like, alright, look already. So, you can see even now, even though the solder isn't complete, the solder's already solid, right? So that's one issue with this. So you see how it kind of, the wire just sucks up solder now. If smoke's billowing in your face like this, I recommend you don't breathe in. I know it says it's safe, but still, you don't want particulate matter in your lungs. It just sucks up solder. So I'm going to recommend you guys don't use this gauge of wire when you start soldering because it's really thick and it takes a lot of solder. But the nice thing about solder is, if you're soldering a connection and you mess up, you can do something called desoldering. And there's this material, and it's kind of like a comes in spools, and what it is it's kind of like a filament, and you solder and you hold this desolder in between your iron and your rosin core, and it will suck up the rosin core out of the wire. And it's generally how you're supposed to desolder things. So please note, this is a really bad soldering job. This wire is so thick, but you guys feel the wire, feel how hot that is. So then what you do is you take your heat shrink around. Do we have the microwave? But so essentially what you'll do is you'll move your heat shrink over, and you kind of want an even distribution on each side. So you always want overlap with your heat shrink, right? And then how do we get the heat done here? So you want to try it? We'll use this thinner gauge because it's less ridiculous. So another thing about heat shrink is that heat shrink also comes in gauges because it can only shrink so much. But we have this gigantic gauge. I wonder if it'll work. So, all right, go ahead. You cut off that connection because that one.